This is SpaceTime, Series 21, Episode 5. Coming up on SpaceTime, SpaceX wrapped up a record 17 launches last year, more than half of all the 29 orbital flights carried out by the United States. Space tourism moving a step closer, with Blue Origin's latest test of its new Shepard launch system. And oops, Moscow's space heart skips a beat as another Russian satellite suddenly goes quiet. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A Dragon cargo ship loaded with fresh supplies has successfully docked with the International Space Station 2 days after launching aboard a Falcon 9 rocket from the Cape Canaveral Air Force Base in Florida. The Falcon 9 blasted off into clear blue skies, with the first stage returning to the launch facility following MECO, or main engine cutoff, and stage separation.
The pad water deluge system will be activated at T-minus 18 seconds.
30 seconds and counting.
The main engine controller will command the engine sequence start 3 seconds away from liftoff. T-minus 20 seconds.
Stage 1 pressing for flight. T-minus 15. Minus 10. 9.
8, 7, 6, 5, 4, 3, 2, 1. And the liftoff of the Falcon 9 rocket and Dragon spacecraft, filled with science and supplies for humanity's research outpost in low Earth orbit, the International Space Station.
SpaceX ascent commentary will be performed by several people. The propulsion engineer calls out propulsion events. The avionics engineer calls out avionics health and Dragon separation. The range coordinator calls out Air Force satellite control network acquisition and loss of signal. And the ground station specialist calls out the SpaceX antenna acquisition and loss of signal.
At 1 minute 5 seconds after liftoff, Falcon 9 reaches transonic speed. The vehicle will pass through an area of maximum dynamic pressure, known as max Q, at 1 minute 18 seconds after liftoff. This is the point where mechanical stress on the rocket reaches its peak because of the rocket's velocity and resistance created by Earth's atmosphere.
Around 2 minutes 24 seconds into the flight, the 9 Merlin engines will sequentially shut down, and you'll hear the call MECO, which is main engine cutoff. This first stage will perform a boost back burn about 15 seconds later, heading back to nearby Cape Canaveral Air Force Station Landing Zone 1.
Evac engine chill has started.
1 minute 50 seconds into the flight of Falcon, carrying Dragon toward the International Space Station. Standing by for main engine cutoff.
We have MECO.
And we have MECO, main engine cutoff. All 9 Falcon 9 engines have shut down as planned.
And the first and second stages have separated as planned.
7 seconds after separation, the second stage's single Merlin vacuum engine ignites to begin a 6.5 minute burn that brings Dragon into low Earth orbit. The engines produce 210,000 pounds of thrust. At 3 minutes 4 seconds into flight, Dragon's protective nose cone, which covers Dragon's berthing mechanism, will be jettisoned.
3 minutes 8 seconds into flight, and the first stage boost back burn has shut down as expected. Second stage carrying Dragon continues on its way toward the International Space Station. 4 minutes 10 seconds after launch, the first stage apogee has been reached, its highest point of orbit. Everything continues normally with the second stage carrying Dragon. First stage entry burn is scheduled to begin 6 minutes 23 seconds after launch, about 10:42 a.m.
New Hampshire acquisition of signal.
The New Hampshire tracking site acquires the second stage in Dragon. Meanwhile, the first stage of the Falcon heading back toward Cape Canaveral Air Force Station Landing Zone 1, 5 minutes 31 seconds after launch.
Stage 1 entry burn startup.
And Stage 1 entry burn is underway. It's a burn of about 10 seconds.
Stage 1 entry burn shut down.
Falcon 9 first stage headed back toward Cape Canaveral Air Force Station, where it launched 6 minutes 37 seconds ago.
Stage 2 performance nominal.
Everything going well with Stage 2 carrying Dragon to the
Stage 1 AFTS has saved.
International Space Station.
Stage 1 is transonic.
Stage 1 is past the speed of sound. It's now subsonic.
Landing burn startup.
Landing burn underway. First stage landing legs will be deployed shortly. And a sonic boom passes across the Florida Space Coast as the Falcon 9 first stage makes a pinpoint landing back at Landing Zone 1 at Cape Canaveral Air Force Station.
LZ-1, the F-9 has landed. Landing operators proceed to procedure 11.100 in Section 3 on LZ-1 net.
Meanwhile, in space, Stage 2 of the Falcon 9 continues to carry the Dragon spacecraft. We're 8 minutes, 12 seconds after launch, less than a minute away from second stage engine cutoff. That's scheduled for a mission lap time.
Countdown.
9 minutes, 5 seconds.
Second stage AFTS has saved.
10 seconds away from second stage engine cutoff.
MECO.
And SECO is confirmed. In about a minute, at a mission lapse time of 10 minutes, 5 seconds, Dragon will separate from Falcon 9's second stage, and seconds later, Dragon will reach its preliminary orbit.
Acquisition of fleet on Newfoundland.
Standing by for spacecraft separation. And Dragon is making its way away from the Falcon 9 second stage, headed toward its destiny and a rendezvous with the International Space Station on Sunday.
At 12 minutes into flight, the Dragon will deploy its solar arrays, and then after that begin a carefully choreographed series of Draco thruster firings to reach the space station. Less than a minute away from solar array deploy.
Dragon makes its way away from the second stage. First part of its mission underway.
Dragon's propulsion system has successfully primed and all thrusters report ready for firing.
Once the Dragon arrived at the International Space Station, crew used the robotic Canadarm to grab the capsule and dock it to the orbiting outpost's Harmony module. The Dragon Series 13 was carrying some 2,205 kilograms of supplies. This included some 711 kilograms of scientific equipment, 490 kilograms of crew supplies, 189 kilograms of space station equipment, 5 kilograms of new computer technology, and 165 kilograms of spacewalk equipment. CRS-13 is also carrying some 645 kilograms of unpressurized cargo, including NASA's total and spectral solar radiance sensor and a space debris sensor. The Total and Spectral Solar Radiance Sensor, or TSIS-1, will be mounted outside the orbiting outpost to measure the Sun's energy output on Earth. The new instrument's 3 times as accurate as previous equipment, allowing scientists to study the Sun's influence on Earth's ozone layer, its atmospheric circulation, as well as clouds and ecosystems. The observations will provide a better understanding of the effects of solar variability on the Earth. The other new piece of equipment to be attached to the outside of the space station will be the Solar Debris Sensor. It's designed to monitor small impacts over the next few years caused by small-scale space debris, things like micrometeoroids. The sensor records the time and scale of impacts from relatively small space particles using dual-layer thin films, an acoustic sensor system, a resistive grid sensor system, and a sensor-embedded backstop. The data provided by the space debris sensor will improve safety by monitoring impact events, and so provide more accurate estimates of how much small-scale debris is really orbiting the Earth near the space station. Also aboard the Dragon was specialized scientific equipment for research into manufacturing fiber optic filaments in a microgravity environment. The flight was also the second mission to successfully reuse a previously flown Dragon capsule. In this case, the Dragon was previously used on CRS-6. The mission also used a previously flown Falcon 9 rocket, that booster having flown on CRS-11. The flight was also the first launch from Space Complex 40 since the failure of the Amos-6 mission during a pre-flight static fire test back in September 2016. The resulting explosion destroyed the Falcon 9 rocket, its Amos-6 satellite payload, and much of Space Launch Complex 40 and its ground equipment. You're listening to SpaceTime. I'm Stuart Gary. Blue Origin has conducted another successful test flight of its reusable new Shepard launch system. The flight saw the spacecraft blast off from the company's West Texas launch pad on a ballistic suborbital trajectory. After a few moments of freefall, the booster reignited its main engines, undertaking a flawless autonomous vertical landing on the launch pad. The crew capsule was fitted with 12 scientific payloads and a test dummy appropriately named Mannequin Skywalker. It separated from the main booster after about 2.5 minutes, eventually reaching an altitude of 99.39 kilometers, surrounded by the inky blackness of space, with just a thin blue line of atmosphere visible on Earth's limb. Meanwhile, after reaching its own apogee, the crew capsule also began falling back to Earth, eventually releasing 3 parachutes and firing landing thrusters in order to cushion the touchdown. The entire flight lasted just 10 minutes. It was the latest in a series of tests of the new launch system, designed to take both scientific and commercial payloads, as well as scientists and tourists, on ballistic flights to altitudes of 100 kilometers or 330,000 feet, the official start of space. As part of that space tourist goal, the new Shepard capsule's equipped with the largest windows ever fitted to any spacecraft, providing unparalleled views of the ride. In fact, the windows are 1 metre in height and almost 3/4 of a metre wide. For comparison, the windows on your typical Boeing 747 or Airbus A380 are only around 1/3 of a metre in height and even less than that in width. The new Shepard is named in honour of Alan Shepard, the first American astronaut to reach space, also on a suborbital trajectory in his Mercury Freedom 7 capsule mounted on top of a Redstone rocket. This is Space Time. I'm Stuart Gary. If you want more Space Time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary. At SpaceTime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. An Ariane 5 rocket has successfully carried 4 European Galileo navigation satellites into orbit. Ariane blasted off into overcast skies from the European Space Agency's Kourou spaceport in French Guiana.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage des 2 EAP et décollage Ariane 240 Galileo Falcon 7.
And we have left off.
La propulsion est nominale.
The rocket now already approaching.
Tous les paramètres à bord sont
there they go, blazing a trail across the sky here over the spaceport, the Guiana Space Center. We're heading northeast out over the Atlantic Ocean, and we can hear the launcher as she flies over us here. We're about 20 kilometers from that pad. We reached Mach 1 after 45 seconds when we broke the sound barrier.
And Mach 2 now.
And right now it's the boosters that are doing all the
Tous les
work.
paramètres à bord sont normaux.
She's telling us that everything on board is going to plan. They are providing 90% of our thrust right now. That's the equivalent of 12 jet engines, and their job is to push us away from the gravity of our planet. We need a lot of firepower to do that. She's telling us that the propulsion is going normally. Each booster is burning 2 tons of propellant per second, and that's roughly the equivalent of what an average car would use in a year. And they're using it in a second. Unbelievably, those boosters are burning at roughly 3,000 degrees Celsius, and yet the main stage is burning cryogenic propellant, which is at absolute zero. It's the coldest temperature you can get, so you can just imagine the complexities of balancing and keeping those two temperatures next to each other, the extremely hot and the extremely cold. It's a feat of human engineering. And she's announcing separation now of those 2 boosters. We don't need them anymore, and they can be jettisoned. We've lost about 3/4 of our weight. The lighter we are, the faster we can go, and we're now burning the main stage. It's a huge tank of cryogenic propellant, which is liquid hydrogen and liquid oxygen. It burns for about 9 minutes.
Tous les paramètres à bord sont normaux.
We'll be able to see what we call a fairing. That's the front, the nose, if you like, of the launch vehicle.
La propulsion est nominale. Tous les paramètres à bord sont normaux.
And she's telling us that everything is normal. Everything's going according to plan. So the fairing, that's the nose, the pointy bit of the launcher, and the fairing is the section which protects the satellites from the rigours of the launch. Those rigours include the acoustic vibrations at liftoff. You can just imagine there that it's very loud. So our satellites are now exposed to space. We took off from the northeastern coast of South America, and Galileo is the... She's telling us that everything's going according to plan still. Galileo is the tracking station here at the Guyana spaceport. SNA is the next tracking station to pick us up. That's a boat in the middle of the Atlantic. And then we'll be heading up towards the northwestern coast of Europe, and we'll be picking up the signal at the Azores.
The successful launch leaves only one more flight before the Galileo satellite constellation is complete. Arianespace flight VA240 was carrying Galileo satellites 19 through to 22. The first two of the 715-kilogram satellites deployed into a 22,922-kilometre high elliptical orbit 3 hours and 36 minutes after liftoff, with the second pair released 20 minutes later. The quartet will be manoeuvred into their final operational circular orbits over the next few days. That'll be followed by 6 months of tests and checkouts before being cleared for use. The mission brings the Galileo system to 22 satellites. The final group of 4 Galileo satellites will be launched aboard Ariane 5 around the middle of next year. That will allow a constellation of 24 satellites plus 2 orbiting spares. Meanwhile, ESA has already begun preliminary design work on what will become the second generation of Galileo satellites. I'm Stuart Gary. You're listening to SpaceTime. Okay, let's take a quick break from the program so I can tell you about our new deal. We have a great offer for listeners of SpaceTime. Audible's offering a free audiobook download and a free 30-day trial. How about Earth Shadows by Daniel Aronson, or Not Alone by Craig A. Faulkner? So many great books, no matter what your taste. Over 180,000 titles to choose from. And no need to rush. Not only do we give you a free book, but you'll have a 30-day free trial to browse to your heart's content. To download your free audiobook today, go to audibletrial.com/spacetime. Again, that's audibletrial.com/spacetime for your free audiobook. Or you can click on the link at spacetimewithstuartgary.com or in the show notes. And now, back to the show. Beijing has successfully launched another LKW, or Yaogong Weijing 32 series Earth observation reconnaissance satellite for the Chinese military. The mission flew from the Jiaquan Satellite Launch Center in the Gobi Desert region of northwestern China's Gansu province aboard a Long March 2D rocket. It was the second launch in 3 weeks of one of these new generation advanced Chinese spy satellites. Officially known as a land survey satellite, the LKW-2 was placed into a 488 by 504 kilometre high low Earth orbit. The launch was timed to match the orbital plane of its sister LKW-1 satellite, thereby providing 180-degree separation between the two spacecraft, a factor providing optimal spacing for reconnaissance and observation. The LKW series appear to be a new generation of advanced electro-optical reconnaissance spacecraft, based on the original 1,000-kilogram Xiaobing 6 series. I'm Stuart Gary. This is SpaceTime. SpaceX has capped off a busy 2017 with the launch of 10 more Iridium Next communication satellites. The mission aboard a Falcon 9 rocket blasted into orbit from Space Launch Complex 4E at the Vandenberg Air Force Base in California.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff, Falcon 9.
Vehicles cleared the tower. Radar propulsion nominal.
Moving to 3.170.
Power and telemetry are nominal.
T plus a minute 10 into flight. We've just gone through throttle down and throttle back up of the Falcon 9 first stage engines. We've gone through max Q on the first stage. First stage continues to look good on the engines, headed downrange away from Vandenberg Air Force Base. We're chilling in the MVAC engine 2 minutes into flight, getting it ready for ignition. Next major event coming up in 30 seconds is shutdown of the 9 first stage engines, followed by stage separation and ignition of the second stage engine. Shortly after that, payload fairing separation from the second stage.
Stage separation confirmed. Please back from startup.
We've had successful separation and ignition of the upper stage engine. First words from propulsion, things look good on the upper stage engine and the second stage. Next up, we should see fairing separation.
Fairing separation confirmed.
You hear the applause from the team gathered around Mission Control Center here in Hawthorne. It's 5:30 in the evening. Second shift is in. They're watching the flight. Fairing separation looked very good, exposing the 10 Iridium Next satellites to the vacuum of outer space.
The setting sun backlit the rocket plumes from both the Falcon 9 core and upper stages, giving the evening sky an eerie appearance which triggered widespread alarm and even panic among some Californians, with reports ranging from UFOs to giant spacefish. The mission was the fourth launch of second-generation Iridium Next telecommunications satellites. The first 10 Iridium Next spacecraft were launched back in January, followed by subsequent launches in June, October and now December. This brings the total number of the new generation satellites in orbit to 40. Iridium planned to have an overall constellation of 75 spacecraft, meaning at least 4 more launches are planned. Each of these new 860-kilogram spacecraft are based around Thales Alenia Space's Extended Lifetime Bus 1000 platform, equipped with L-band transponders to communicate with satellite phone users and Ka-band transponders to communicate with other satellites in the constellation and with ground stations. The launch was the 5th time SpaceX used a flight-proven Falcon 9 core stage. This one, Core 1036, was previously used on the second Iridium launch back in June. The core is part of the earlier, now superseded Block 3 production run, which has now been replaced by the current more powerful Block 4 series. SpaceX only flies Block 3 core stages twice, so this mission was flown in an expendable configuration, without landing legs, although grid fins were apparently fitted to help control where it hits the ocean. The launch marked the 46th flight of the Falcon 9. The mission also gave SpaceX a record 17 launches for the year, more than half of all 29 flights carried out by the United States in 2017. I'm Stuart Gary. You're listening to SpaceTime. Japan has launched an H-2A rocket carrying a spacecraft designed to monitor the planet's worsening climate change. The Global Change Observation, or GCOM-C1 spacecraft, blasted into orbit from the Tanegashima Space Center south of Tokyo.
Turning the flight mode on. All systems are go. Activating the thermal batteries. Main engine ignition. We have a liftoff of the H-2A launch vehicle number 37 carrying Shikisai and Tsubame from the JAXA Tanegashima Space Center at 10:26:22 a.m. on December 23, 2017 Japan Standard Time. Following liftoff, the operation control of the launch vehicle has been switched from the blockhouse to the range control center. The H-2A is now flying above the Pacific Ocean to the southeast. The H-2A is flying nominally. Here at Tanegashima, tracking is proceeding well. The combustion of the first stage engine attitude control and trajectory are all nominal. The H-2A flight is on course. Current altitude is about 80 kilometers, approximate velocity 1.3 kilometers per second.
The 2,093-kilogram spacecraft was renamed Shikisai once it reached orbit. It's expected to operate for at least 5 years from a circular 798-kilometer high sun-synchronous orbit. The spacecraft will study long-term changes in Earth's climate and hydrological cycles caused by the increased use of fossil fuels such as coal and oil. It carries an imaging payload designed to monitor long-term changes in Earth's climate and will study the distributions of aerosols, water vapor and clouds in the atmosphere. The probe will also monitor the colour and temperature of the oceans as well as the extent of snow and ice cover, and it will monitor changes in both vegetation and land usage. The mission also carried SLATS, the Super Low Altitude Test Satellite, a 400-kilogram spacecraft deployed into a lower orbit after the GCOM-C separated from the H-2A. SLATS was renamed Tsubame, meaning swallow in Japanese, following its deployment. Its primary mission is to test the new ion engine, which will allow the spacecraft to fly at very low altitudes without re-entering the atmosphere. After its deployment, SLATS used 4 hydrazine thrusters to drop down into an orbit as low as 180 kilometers in altitude, low enough for atmospheric drag to cause the spacecraft's orbit to decay rapidly. The probe will then use a xenon ion propulsion system powered by solar panels to maintain altitude. The spacecraft is carrying 10 kilograms of xenon propellant. That's enough to keep it in orbit for at least 2 years. SLATS is also carrying 3 onboard experiments. There's an atomic oxygen fluence sensor. It uses 8 quartz crystal microbalancers to monitor the mass of polyamide film samples that will decrease in mass as the film reacts with oxygen in the upper atmosphere. This should allow the amount of atomic oxygen present to be calculated. There's also a material degradation monitor. It uses a camera to observe material samples attached to the outside of the spacecraft in order to see how they're affected by exposure to near-Earth space. And there's an optical sensor using a small camera to image Earth's surface. It's designed to see how much, if any, improvement in imaging resolution can be achieved by placing satellites into really low orbits. This is Space Time. I'm Stuart Gary. The Russian Federal Space Agency Roscosmos says it's re-established contact with a telecommunications satellite that suddenly went quiet after launch. The ANGOSat-1, Angola's first satellite, was launched aboard a Zenit 3SLBF rocket from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan. However, ground stations lost all contact with the spacecraft shortly after its deployment from the launch vehicle's Frigate SB upper stage. It's understood contact dropped off as soon as the satellite's solar arrays were deployed, one of the first things usually done when a spacecraft reaches orbit. Luckily, a day after the glitch, mission managers were able to re-establish communications with the spacecraft, saying all systems now appear to be in good health. However, any issue involving the solar array could affect onboard battery performance, so it'll be interesting to see what happens. The 1,647 kilogram ANGOSat-1 was a rare export order for RSC Energia, and its failure would have been another catastrophic blow for Russia's beleaguered space industry. Moscow is still coming to terms with November's multi-million-dollar failure of a Soyuz launch vehicle carrying the Meteor M21 weather satellite, as well as 18 secondary satellite payloads. The ANGOSat-1 is designed to provide television, broadcast, internet and radio communication services using 16 C-band and 6 Ku-band transponders. The spacecraft took 8 years to build and has a design life of 15 years, with a footprint stretching across Africa and southern Europe. The 60-metre-tall Ukrainian-built Zenit launch vehicle was the last rocket design developed by the former Soviet Union. It was originally intended to eventually replace both the Soyuz and Proton launch vehicles, but these plans were dropped following the demise of the Soviet Union in 1991. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from SpaceTimeWithStuartGary.com, or from your favourite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and as part of Virgin Australia's in-flight entertainment. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Today's episode of Spacetime was brought to you by Audible.com. Help support the show and get your first book for free, plus a 30-day free trial. Use the link www.audibletrial.com/spacetime. That's www.audibletrial.com/spacetime for your free audiobook.